Welcome to today's lesson with Mrs. H about four-sided polygons. So our first test is going to be, it says it can only be made up of straight segments only. So I'm going to put a rectangle around every one that's true. So a squall, that's true. A lightning, that's true. The cumulus cloud would not work. Snow, that's true. This type of cloud, true. Hail, true. And showers, true. So haze and tropical storm would not be true. Now, it says, does each line segment in the symbol intersect at exactly two other line segments? So no more at each end point. So we're going to put a circle on those. So that's true for a squall. Okay. It's not true for lightning because this endpoint doesn't intersect with two other endpoints. Okay. Snow would not be true because it intersects multiple times. Again, the cloud would not be true. There's no connection here. Hail would work and showers would work. So the three that are both a square and a circle that we went through are considered polygons. So what is the fewest number of sides a polygon can have? Well, hopefully we recognize that can be 3. Because if we go down to 2 sides, we can't make a connection with the third side. And then what is the greatest number of sides a polygon can have? And there actually is no max. So this could go on and on and on and on and on. So basically, a polygon is a figure with 3 or more sides, and the line segments must be straight, so no curves, and each side must intersect exactly twice with another side. Okay? And then types of polygons are named by their number of sides. And hopefully we know what a 3-sided polygon would be. That would be a triangle. And then a 4-sided polygon is known as a quadrilateral. And there are so many different types of quadrilaterals that we're going to learn about. Okay. And then another vocabulary word for us is a diagonal or diagonals of a polygon are segments that connect any two non-consecutive, that means not right next to, vertices. So first of all of these endpoints are considered vertices. Okay, and then here's a diagonal, diagonal. Okay. All right, let's go to the page. So deciding if something is concave or convex. So if all diagonals are inside the polygon and all interior angles are less than 180, then the polygon is convex. If at least one of the diagonals is not inside the polygon or interior angle is greater than 180, then the polygon is concave. So what I like to think of it as thinking of it caving in. So concave is like going into a cave. So then that means we'd basically have an indent in our polygon. So for the first example, notice we don't have any indentations. So this would be considered convex. The second one, we do have an indentation. It's going inside. So this would be concave. And then the third one, you might think it's concave, but that would be incorrect because in order to be concave or convex, it needs to be a polygon first. This is not a polygon because this is not made up of all straight lines. Okay. To name polygons, we basically start at one vertex and then you proceed either counterclockwise or clockwise. So think about a triangle, we say triangle ABC. Well, now a quadrilateral is going to have 4, so we're going to say triangle ABCD, or excuse me, quadrilateral ABCD. Okay, this one is a hexagon, So we're going to say this is A, B, C, D, E, F. Just make sure that you don't crisscross. So don't jump from like A to C to F to D to B to E. Okay, it's got to go in one direction. The next one actually is not a polygon because of the fact that it crosses over. Okay. In the next example, we can actually say this is made up of two polygons. So we can say PRO, or we can say KPOM, or we can even say KPROM. So notice that there were several different, we have a triangle, we have a quadrilateral, and we have a pentagon. Okay. All right. One thing we're going to work a lot with is the sum of the measures of the interior angles of a quadrilateral. So a triangle is 180, a quadrilateral is 360. So notice that if you have a quadrilateral, which is four sides again, a diagonal divides the figure into two triangles. Well, how many degrees are there in a triangle? Well, if we add up angles 1, 2, and 3, that's going to be 180 degrees. If we add up triangles 4, 5, and 6, that's going to be 180 degrees. Therefore, which, by the way, that's what those little three dots mean. Therefore, the sum of all six angles is 360 degrees. Okay? All right, so we're going to use the information to solve for x. So first of all, you have to decide what type of polygon it is. And if we count off the sides, there's four sides, so this is going to be a quadrilateral. A quadrilateral should have four angles, just like a triangle should have three angles. And we're going to add this all up to equal 360 degrees. Okay, so we get x plus 253 equals 360. So x equals 107. Just remember, a quadrilateral should have four angles when you add them all up together. Okay, and then same thing with the next example. So remember that these mean 90 degrees. So add up all four. To equal 360 degrees, and then you would just solve that. Okay. All right, next page notes. Now we're going to start talking about special quadrilaterals. So remember that a quadrilateral is a four-sided polygon. Okay, but there are special types of quadrilaterals. The first is a parallelogram. A parallelogram, of course, has four sides congruent, or excuse me, four sides total. And then it has opposite sides parallel, opposite sides congruent, and opposite angles congruent. So when I start talking to you about a parallelogram, you need to know these properties. So if this was our parallelogram, we would say that opposite sides are parallel. Okay. We would say that opposite sides are congruent and opposite angles congruent. So really important characteristic to know about parallelograms. Okay. A rectangle has all of this true, but then it has some special extra characteristics. One is that all angles are right angles. And two, the diagonals are congruent. Okay. A rhombus again, all these are true. And it has special characteristics that all sides congruent and diagonals are perpendicular bisectors, which just basically means that the diagonals are perpendicular and they bisect each other. Okay, a kite, we take a little break here. A kite is not a parallelogram. By the way, that's the shorthand version to say parallelogram. Okay. A kite is disjoint pairs of consecutive sides are congruent. And one diagonal is a perpendicular bisector. So what this means is that here is a picture of a kite, and that disjointed pairs, so basically that means not the ones that are opposite each other. So these two and these two are going to be congruent. So let's go ahead and mark those. So congruent, congruent. And then one of the diagonals is a perpendicular bisector. So if we draw in both diagonals, okay, this one would be the one that would be bisected. Okay, and perpendicular. All right, moving on to a square. A square, all true, so opposite sides parallel, opposite sides congruent, opposite angles congruent, and all sides congruent, all angles right angles, and diagonals are perpendicular bisectors. Okay. And then finally, I know there's a lot. Don't worry, we're going to be practicing these quite a bit. We've got a chart for tomorrow, or the next lesson, I should say. Trapezoids are not a p-gram. Basically means parallelogram. And what they are is one pair of opposite sides are parallel. So instead of having both pairs, only one is. So opposite sides are parallel. And basically, it's the bases of the isosceles, or the trapezoid. Sorry, I was thinking of the next example already. So this would be an example of a trapezoid. Okay. An isosceles trapezoid is just where the legs are congruent. So like this. So these would be parallel, and these would be congruent. Okie dokie. We are going to save the always, sometimes, never, which is on the next page, as a class. Thanks so much for watching.